When an artificial intelligence prototype is finally moved into a real-world business environment, tracking whether it is actually doing a good job becomes a massive challenge. The numbers tell a difficult story. A major 2025 study of engineering teams found that a staggering 93% of them fail when they try to build systems that allow an AI to monitor its own quality. The reason these systems fail is simple. These models have a built-in positivity bias. They are designed to be helpful and agreeable, which makes them terrible at self-criticism. It is like letting a student grade their own final exam. You are relying on a system that is naturally inclined to give itself a perfect score, even if the work is full of mistakes. If you ask an AI a direct question like, "Is the work you just did correct?" it will almost always say yes. It isn't trying to lie, it just doesn't have the perspective to see its own flaws. Relying on a single AI to both create the work and check the work creates an illusion that everything is running smoothly. To get a real answer, we have to change how the entire system is built. The first step is to split the system in two. We have to separate the part of the AI that creates the content from the part that verifies it. We call the first role the optimizer. Think of it as a creative writer. Its only job is generating raw material as fast as possible. The second role is the evaluator. This strict editor with a red pen has one job: to find reasons to reject what the writer produces. These two roles are in constant opposition. The optimizer works to solve the task, while the evaluator checks that work against a specific set of rules to ensure it meets the mark. If the evaluator finds a mistake, the work is rejected and sent back to the optimizer. The writer is then forced to try again until the editor is satisfied. This creates a continuous loop of feedback. By splitting the work this way, we finally stop the agent from being its own judge. Even with two separate agents, a hidden problem remains. Just because they have different roles doesn't mean they think differently. This is called preference leakage. Notice how both the optimizer and the evaluator pulse with the same color, representing a shared bias deep within their code. Because both agents are built on the same model, they share the same DNA, writing taste, and logic. This means the strict editor is often just a mirror image of the writer. It likes the writer's work because the work sounds exactly like something the editor would have written itself. Because of this shared style, the evaluator might approve an answer that sounds confident and familiar, even if the information inside is completely wrong. To break this cycle, we have to stop the evaluator from relying on its gut feeling. We have to force it to use a system that is mathematically rigid. To strip away those shared biases, we replace vague opinions with specific performance requirements. A vague score of 7 transforms into a standardized checklist of concrete actions. We shuffle the order of these items every time. This prevents positional bias, where models lazily agree with the first thing they see. Shuffling forces the judge to process every requirement individually. The most important safeguard, however, is a technique that forces the AI to show its work. We require the judge to write out its step-by-step logical reasoning first. It is not allowed to give a final score until it has proven its logic in writing. Finally, the system monitors the loop for score plateaus. This happens when the optimizer and evaluator get stuck, repeating the same mistakes over and over. If the score stops improving, the system detects the stall and automatically injects a completely different strategy. This prevents the agents from wasting time and money on a loop that isn't going anywhere. By using these rigid controls, we can turn a biased AI into an objective judge. We move away from conversational guesswork and treat AI quality like a strict professional code review.